and then we're gonna shut the acetylene off. We do that so we get a safety check every time we turn off the torch. If your torch pops, it tells you that this valve is leaking. If you have an orange flame stuck to the tip, it tells you that your acetylene gas valve is leaking. If you turn the acetylene off first, your torch is going to pop every time, and it is going to throw carbon down inside the torch to the point where the gases mix, which is right here. And eventually, that will either burn out the mixer or clog it up. Okay? The way the torch, the bottom barrel is our preheat, our mixed gas. The top one, when we depress our lever, we just comes out to the center hole that does the cutting. Does everybody realize that oxygen is what's doing the cutting? When we use a torch, we preheat the steel. It's got to have iron in it, okay, and to its kindling temperature. When we depress the cutting oxygen lever, the iron oxidizes, and it is blown out of there, it's oxidized and removed from the material. That's what's doing the cutting. All the preheat flames do is heat the steel to that kindling temperature where we get that chemical reaction between pure oxygen and the iron that's in the steel. That's why we can't cut aluminum or stainless and some of the other items. If we don't have the iron in the steel, we don't get that chemical reaction. Doesn't matter how long, how much preheat I put to it. Okay? The other thing I'll tell you and dispel some myths is it doesn't matter what fuel gas you use. I can cut within an inch a minute with natural gas, which is got the coldest flame temperature and the lowest BTUs, as I can with this up. Now, it may take me longer to get to that kindling temperature where I can pierce it. It may take me a little longer to get there, but once I get my cut started, I'm within an inch a minute. I'm going to adjust my tip so that I can make my preheat flame. If I've got low preheat, I'm going to make a bigger preheat flame so that it gives it more time to heat as I cut. Okay? All right. Any questions on lighting and setting our torch?
Yeah,
Yep.
I noticed when you're messing with the knobs, you're only messing with the
This one
acetylene
and
that
this one.
What's the other knob for?
This is what we call a combination torch. Okay? I take it apart and I can put a welding nozzle. Okay? Now I can braze, solder, or weld. I can put a heating head on it. Okay, and now I can heat. And at this point, I'm going to use just these. I'm going to use my oxygen here, my acetylene here.
So you leave your oxygen on?
Yes, when I use my cutting attachment, okay, I need to adjust it here. So I will open my oxygen valve all the way and leave it open all the way. Okay? You don't ever want to use this to try to adjust with the cutting attachment.
I just didn't
That's all
see you
it is.
mess with that one, I just seen you mess with that one.
Absolutely. Great question. Shame on me. I should have said that in the very beginning. Any other questions? Okay? Now we're done. We're going to shut down. We're done for the day. We're going to bleed our torch, one gas at a time. Well, first we got to shut our cylinders off, obviously. Shut our cylinders down. And by the way, I'll just say this. It doesn't matter how you have this. You know, there's O-rings in here. I will tell you, I find keeping them all lined up. I'm right-handed, so for me, whatever I'm doing, my valves are out of the way. I find this easy, plus whenever I light, everything's just right here. Doesn't mean that it's the only way to do it. Talked to a guy the other day, and he was like this. To me, this gets in the way of my hand and I hit it. You gotta find out what's comfortable. I'll tell you, this direction is probably might be the most common, I don't know. But anyway, that's how I do it. All right? This old style had flats. Those are not wrench flats. When we put an attachment on, we always hand tight them. There are 2 rubber O-rings in there that we need to make sure that they're there. If you have a leak there, check your O-rings. Okay? They're easy to replace. Do not go to the hardware store and buy an O-ring. You go to that guy and get the O-ring. Because a lot of O-rings are going to have petroleum on them. And what are we doing? We're sticking them right in there on oxygen. Okay? Make sure you use the right stuff on the tool. Okay, we're done. We're shut off. We're going to shut for the day, or shut down for the day. We're going to shut our cylinders off. I'm going to go back to my torch. I'm going to bleed each torch off, or each gas off. Let it drop down. Then I'm going to shut it off. Do the other one. Then I'm going to turn my adjusting screws out. I'm going to wrap everything, clean it up, and go. Now, why do I keep going on and on about turning our adjusting screw out? I can almost guarantee that 90% of your regulators probably haven't moved in 6 months. Okay? That is the nature of this industry. I was at a steel company earlier this week. We did one, and everybody laughed, and sure enough, we walked out there and every single one of them, was turned in. The way a regulator works, we got high pressure gas coming in here, and it comes into, got a pin here, a little better pointer. It comes into this high pressure seat area, okay? If my adjusting screw is out, this seat is closed. Gas does not flow past that point, okay? Once I turn this adjusting screw in, I'm pushing down on the needle. It opens up the seat, gas flows up to here and out to the torch. Once it gets to the right pressure, the pressure builds up inside the regulator and shuts or restricts that seat area to give you the proper amount of gas flow. Okay? Very simple device. Very safe. If for some reason this leaked, if it would come out, we have a reseatable safety. This will pop off and reset itself. Most of the time, that's all that's needed. In the extreme case that this failed, or what has happened is somebody says, well, that safety kept doing, so they took it out, they put a 1/4-20 plug in it. They got it true value, stuck it in there, so now we defeated our safety. Pressure continued. We haven't fixed the regulator. They just fixed the safety or took it out. So it will build up and it will actually punch holes in this diaphragm and the gas will expel out the side. Okay? If you have a problem, send it in and get it repaired. It's a very simple device. I noticed you have a lot of the edge regulators. There it is. Okay, it's built the same way. This regulator is got a couple safety features that regulator does not. This is like the bumper of a car. This will absorb over 5,000 foot-pounds of energy. So the idea is if your bottle fell over, like we talked about with the oxygen and the Mythbusters deal, when it hits, this crushes and it helps prevent the valve from shearing and sending off like a missile. It also has a patented chamber behind the oxygen inlet that if you did get a hydrocarbon on here, it acts like a little catcher's mitt, catches it, diffuses the oxygen, and keeps the regulator from blowing out and blowing parts. Okay? So when you look at this, it's not just something different. It just doesn't look different. It actually has a lot of technology built into it. I'll pass some of these along with it that we have test knobs that we've taken empty cylinders and crushed them, and here's a full one that you can actually see the crumple zones the way it's built in.
Can this be used more than once? Say it hits and
The
activates
regulator, yes, you can pull
it can be popped back out.
no, you can't pop the knob. The knob has to be replaced.
Okay, that's what I was
Okay,
asking.
no.
So if it fell over the one time, then you
No,
have to be
it's
replaced.
done.
So it's just one time thing. if it
Yep.
happens.
If it falls over, you'll see the knobs, I mean, they're not gonna come back. But there is a set screw underneath here, you peel off the label, you get you a new knob, you stick it on, you screw it in, and then you're good. You're back in service. Good question. Now, when I started the whole thing with changing out cylinders, I told you you had the highest propensity for, one of the highest propensities for accident, right? Okay. Two things can happen, and we're gonna get ready to go out here in a minute and go through a couple little demos. We can have reverse flow, and we can have flashbacks. Okay, there are some things that happen in torches, and they can happen very, very quickly. We have safety devices to help protect you from those things that can happen. We have check valves and we have flash arresters. A check valve stops the reverse flow of gas. Gas is only going to flow one way into the torch. This is my check valve. If gas tries to come back the other way, that thing closes under just ounces of pressure. Okay, and it stops right here. The problem with a check valve is it won't stop a fire. Okay, if it's open and we had contamination or something in our hose, mixed gas in there, a fire can jump right over an open check valve. I'm going to demonstrate that for you in a little bit. So we put in a flash arrestor. This little piece right here is what we call a flashback arrestor. It will put out a fire. The problem is it doesn't stop reverse flow. It's a stainless steel centered filter, and gas will flow either direction. So I call them my seat belts and airbags for my torches. Okay, they're the two safety devices you need. OSHA requires check valves. OSHA does not, but most insurance companies do require flash arresters, to my knowledge. And OSHA changes things I may not have been up to date. To my knowledge, they don't require it, but I'm sure the city does. Your specs probably spec them in. You want to have them both. I always encourage people to put them on, if you don't have a Vector torch with them built in, to put them on the torch handle. We want to put the fire out as soon as possible. Okay. Let's say we run out of oxygen. Pressure in our acetylene is such that we can get reverse flow, and it can travel back upwards into that oxygen line, into the regulator. Okay, I'm using a torch that doesn't have all this good stuff on it. I go swap out my bottle, and I've left my adjusting screw turned in. Now I got a brand new bottle of oxygen, okay, number one. I've had reverse flow, and I've ended up with some acetylene all the way up in my hose into my regulator. Okay, it's a real possibility. Open up my valve, oxygen starts going. I've left my adjusting screw in, right? You all with me? It starts flowing. That flow creates what? Friction. Friction creates what? Now I've completed my triangle of combustion, right? This is what can happen. I sure as heck wouldn't want to be standing in front of that thing when that dude went. Okay? Follow the simple safety things. I got lots of stories. Was it 2 years ago, 2 summers ago, summer before this, that came Tulsa and helped investigate an accident?
Yep, it was.
Torch just like this, okay? I add stories because it helps you understand what can happen out here in the field. Right here in Tulsa, construction site, guy using this, he was outside, the hose came apart, it had a splice in it, okay? He went back, stuck this splice back together, the oxygen hose back together, went over here, turned on his fuel, lit it, and the torch exploded. Okay? Blew the hose out about 6-8 inches behind the torch. It's a little piece of metal off of here that came off the torch. Blew the stitches out of his glove. That was it as far as any injuries or anything bad. So they asked me to come in and help figure out what happened. Okay, as we started digging in and asking the questions, we found out splice came undone on the oxygen side, stuck it together. So what happened at that point, the fuel came through here and it filled this whole chamber full of fuel. Because it can mix right here. Remember, here's the mixer. And it happens, and I'm going to show you how fast this will happen, and you'll never know it. So now we have fuel going backwards. Look how big this chamber is. There's a lot of room for gases. Now we have fuel, and as soon as he lit it, he opened up his fuel, and now we've got fresh oxygen and fuel mixed. And it wasn't a flashback, it was a flat explosion. Okay? Now the torch is built to the point where to withstand an awful lot of impact. Okay? The force was such that it actually blew the end of the hose off. If he would have followed the simple thing that we just learned today as far as purging it, he would have pushed all that fuel out of the oxygen side. It would have come out, he would have lit his torch, and he wouldn't have ever even known that it was there. Okay? It's the little things. We can have a failure with the regulator. We can have a seat get stuck. Something. It may not be any fault of your own. Let's just make a real habit of following the safety procedures. Any questions? I want to cover how we doing time.
Perfect, you good.
Okay. I wanna cover rosebuds just a little bit. You guys do any heating on anything? Valves loosen up or anything?
They normally just use their torch. Yeah.
Okay. Alright. I won't spend a lot of time on this and I won't make you pull out all your calculators. If you do a lot of heating, we'd go into a lot more depth. Okay, this is an MFA, multi-flame acetylene. I do want you, this same information is on the back of this red tip card. But just for fun, let's open to page 9-42, and it is in the front of the book. This is a trilingual guide, so we're gonna go English in the front. Okay, everybody there? I don't expect anybody to remember this stuff, but you need to know where to go to get the information, okay, if you need it. What's my 2 rules of acetylene? Number 1, we never exceed how many PSI? 15. I never exceed what as far as cubic feet per hour? 1.7, okay. We're gonna use the analogy I use, remember I'm simple, 350 cubic foot cylinder. We have 50 cubic feet available, right? You buy a Victor Journeyman outfit, it is going to come with this rosebud in it, an 8 MFA. 8 is the size, MFA just stands for multi-flame acetylene. If I look on the top of page 9-43, what is my acetylene pressure going to be set at? 10 to 15. What is my oxygen pressure going to be set at? 20 to 30. What is my acetylene cubic feet per hour? Minimum and maximum.
80.
That's my maximum. What's the minimum? 30. Okay. Here's a trick question. Can I use this on that 350 cubic foot cylinder? I have 30 as my minimum, 80 as my maximum. Can I use it? I have 50 available. Yes? But 80 is greater than 50.
You say 350?
350 divided by 7, I have 50 that's really available for usable. Okay, that's the number I'm going to. I'm going to say you're right, but I want an explanation why you think you can.
I think it's because the minimum's 30 and maximum's
Okay.
80. I mean, it's right in between.
Perfect. So how do I know if I'm at 30 or 80 or in between? You're right. Whether you know why or not.
I don't know why. I'm just using the
Okay.
numbers.
I mean, I love it. What is my minimum pressures? 10 on acetylene and 20 on oxygen, right? If I set my regulators to the minimum pressure, I'm going to be at 30 cubic feet an hour. If I set them at the maximum, I'm going to be at 80 cubic feet per hour. We've done the testing for you. Okay? We're telling you in every piece of literature that we put out, books, the tip cards, they're there. And that's why those numbers are there. Okay? I've got a heating job and I want the most heat I can get. So what would you say that you should do to get the most heat? Because the amount of heat is in BTUs, okay? British thermal units. On the previous page, we tell you with acetylene, there's approximately 1,470 BTUs per cubic foot. So with that analogy, the more flow I'm having, the more BTUs, the more heat I have, right?
Yeah.
So if I have 350, 50's in the, right in the middle, and you nailed it, it's perfect. If I turn my regulators to 12 and 25, I'm gonna be right about 50, which would be the maximum that I can use off of that cylinder. To go higher, I need to start manifolding cylinders together. Okay?
That's where it gets ugly, isn't it?
That's when it gets ugly. Now, with that being said, I'm gonna go through lighting a rosebud with acetylene. It's the same way as lighting your cutting torch. Okay? I'm going to purge it. Once I've got my regulator set, okay? I'm gonna purge it, my acetylene, open up my oxygen, run my gas, then turn it off. I'm gonna take my striker to the side of it, I'm gonna crack my acetylene, I'm gonna light it, and I'm gonna continue to open it up until that black sooty smoke goes away. Then I'm going to leave my acetylene alone, I'm going to open up my oxygen until I get a neutral flame. At that point, my torch is set. Guys, these are not gas pedals. You don't, if I want more heat, I turn them up. If I want less heat, I turn them down. That is not how this stuff works. Okay? If you've got too much heat, get a smaller tip, turn the pressures down. We're gonna light it the same way. Okay? If I don't have enough heat, either turn the regulators up within to it, or get a bigger tip, manifold cylinders together. If your torch is set properly, you should be able to light your torch and hold your torch just like this with a bare hand, and this not get hot. If it gets hot, it's telling you you have a flow restriction. We're not getting enough gas through here to where it's burning outside, everything is burning outside, and it's starting to burn down inside the gooseneck. My disclaimer, and I love it, I'm on film even. Once you heat something, once you use this, do not grab this. It will burn the bejeebers out of you. That's reflective heat, okay? Only with a cold torch that has not been lit do you ever do that test, okay? But it's a good test to know, maybe you had to pull it out and we got 100 or 200 foot of hose. You got a lot of pressure drop, we have volume drop. But if it's getting hot, there's a reason, okay? We need to figure out what it is. Fix the problem before we go on. Heating heads cause a lot of problems. Now, I will say this, and then we'll go outside. I don't know if you guys want to break, whatever you guys do. Acetylene is the worst gas that we have for heat. Okay, we already notated that it's 1,470 BTUs. Maximum is 80. If you do the math to see how much heat this can put out, 1470 times 80 cubic feet gives me about 117,600 BTUs. That's how much heat I can get out of this tip. If I change to propylene, which is the second biggest, most popular, that's what you guys have, right?
Yes.
Propylene, if you look, same thing, page 42, right in the middle, it shows propylene 2371. If I have a tip, remember I told you we can run any fuel gas with our torches. Just change the tip, hose, regulator. okay? I've got a Type 55, number 8, same size. We run the same cubic, or very close to the same cubic footages within sizes, that's done intentionally. It's 85 cubic feet. If I do the math, 85 times 2371, I end up with 201,500. I go from 201,000 from 117,000 BTUs, and all I did is change gas. And for just dramatics, the biggest rosebud that we make for a settler takes 330 cubic feet. If you do the math, it gives you 330,000 BTUs. Okay? I need 5 cylinders, those big ones, manifolded together in order to satisfy that tip. Okay? That's gonna cost you about $5 grand for a manifold, probably another 3 for a hydraulic flash arrestor, because that's required by the NFPA. And so I'm, $7,000, $8,000 before I ever even light my torch. And I'm gonna have 333,000 BTUs. If I go to propylene, 105-pound propylene cylinder with a Type 20 or number 20 Type 55 rosebud, I'm going to give you about 1.2 million BTUs out of one cylinder. It's huge. It's safer, it's faster, and it will improve your productivity a bunch. Any questions?
What's that used for mostly? The big,
Heating?
big ones. Big
Lots
monster
of
ones
things.
you're talking about.
A lot of it is preheating for welding. Halliburton, I did a thing down in Duncan several years ago where they had these big valves, and they were using acetylene rosebuds, and they would maybe get 2 valves before they burn it up, because there's a lot of reflective heat in there. They were popping, it was a safety issue. I went down there, we looked at it, had the distributor bring in a gas bottle, propylene. I brought in the tip and the head. We cut the time down, oh shoots, it was, I don't remember, but it was a bunch. And a year later, they were using the same tip. In Tulsa here several years ago, we had a customer that was doing a shrink fit. They were sliding one sleeve over another and then quenching it and sucking it up. They were using 3 guys, 15 minutes to preheat this thing with the acetylene. Okay, to get this thing hot enough to go in. I brought in 2 torches and 2 regulators. Distributor brought in 2 bottles of propylene. We went from 15 minutes to 3 with 1 less person. It's amazing. It really is. And you don't have near the backfire tendency, so it's not going to pop as much. You don't have to worry about the withdrawal rates. Now, if it's cold outside, sometimes you'll need to make sure we have a big enough container so because in a propane or propylene bottle, it's liquid and we're pulling off the head pressure. Okay, if it's warm like this, I mean, it's gonna vaporize and give you all the gas you want. If it's colder in the well diggers, you know what? You may have to have a bigger container if we're using a big one. Preheat on big pulleys and stuff for straightening. There's just gobs and gobs of reasons that you preheat stuff or we heat stuff up. It's to remove stuck valves. It is a big one. Any other questions? It's up to you, you can go right out there if you want to.
Yeah, if y'all wanna take a bathroom break right quick, we'll meet at the shop.